Mr. Right here, and thank you very much to the person who sent in this question, which involves a hemisphere and a cylinder. Let's have a look. Incidentally, if you have a question that you're stumped on, you can email it in to me. You'll find my email address in the description of this film. And then, of course, I'll give it a shot. Right, now in this question, we are told the total surface area of a solid hemisphere is equal to the curved surface area of a cylinder. We're also told that the radius of the hemisphere is r, and the radius of the cylinder is twice the radius of the hemisphere. Now, given all of that information, we're then asked to find the ratio of the volumes of the hemisphere and the cylinder. So let's start off with what we're told at the top here, the total surface area of a solid hemisphere. Right, well, the surface area of a hemisphere is going to be the area of half a sphere, half the surface area of a sphere. There's the formula for the surface area of a sphere. So a half of that plus the area of the circle on the bottom of the hemisphere, because of course a hemisphere will look like this. And so there is the area of the circle here, and then there is the surface area of half of a sphere. So that's the surface area of the solid hemisphere, and we're told that that is equal to the curved surface area of a cylinder. Now, the formula for the curved surface area of a cylinder is 2 pi rh. Now, in this case, r here is equal to 2r, because the radius of the cylinder is equal to twice the radius of the hemisphere. So I'm going to have my total surface area of the solid hemisphere on the left, and that's going to be equal to 2 pi times 2r times h. Now, let's do a bit of simplifying here. So I've got a half of 4 pi r squared plus a pi r squared. So I've got 3 pi r squared on the left, and on the right I've got 4 pi r h. All right, let's divide both sides by pi, and let's divide both sides by r. So that's going to mean that the r goes there, and instead of r squared it's just r to the power of 1. So I've got 3r equals 4h, which tells me h in terms of r. H is equal to 3r over 4. Now, I'm going to have a look at what I'm told about these volumes. So let's go over here, right, volumes. Now, the volume of the hemisphere, well, the formula for the volume of a sphere is 4/3 times pi times r cubed. So I've got a hemisphere here, so that's going to be a half of that. So that's the volume of the hemisphere. Right, now, the ratio of that to the volume of the cylinder. Now, the volume of the cylinder is pi r squared h, but don't forget that r, the radius of the cylinder isn't r, it's 2r, so that's going to be 2r squared. So what I've got here is pi times 2r squared times h. Now, what are we going to have on the left here? Well, a half of 4/3 pi r cubed is 2/3 pi r cubed. And here I'm going to have pi times 4r squared, 2r times 2r is 4r squared, times h, and h is equal to 3r over 4. Okay, now I think I can do some more simplifying here. Let's have a look. Well, on the right-hand side, those 4's can go. Okay, so now I've got, oh, just a minute, and from both sides, I can divide both sides by pi. That's easy enough to see. Let's see what I've got now. 2/3 r cubed, and on the right, I've got 3r cubed. Okay, well, let's divide both sides by r cubed. So now I've got 2/3 to 3. Now I'm asked to write this as 1 to something. The question is, what is that something? So let's multiply both sides by 3. So now I've got 2 to 9, 1 to 4.5. So the ratio of the volume of the hemisphere to the volume of the cylinder is a ratio of 1 to 4.5. And in the question, you're given that as 1 to m, and you're asked what m is. So my solution is that m is equal to 4.5. And that is that one sorted. So thanks very much for sending it in. And if you'd like me to tackle a question, email it in. My email address is in the description of this film. Thanks for watching. See you in the next